Hello, my name is Dr. Thayer Morrill. I'm in the Department of Economics here at NC State. We'd like to thank you for participating in this experiment. So before we get started, we want to go over a couple of things about the overall setup of the experiment and then go through some specific examples to make sure that everything is clear. So first, you may see some other people in the room, but note that none of these people are involved in the same experiment that you are. All the other subjects in the experiment will be played by a computer. The computer, we're choosing schools, and the preferences of the computer subjects will be chosen or just determined randomly. So in each experiment, you're going to be giving a ranking of schools and a certain number of points assigned to each schools. And your sole objective is just to try to get into the school that has the highest number of points possible. You're going to be paid more if you get into a school with more points, and so the better school you can get into, the more money you'll get paid. So the preferences, the computer, like you, will have random preferences, but those will just be determined randomly. So in the different experiments, sometimes there'll be 4 schools, sometimes there'll be 8 schools. It'll just depend on the different experiment, but all of this you'll be able to see. You'll be able to see the number of schools that there are, preferences, the total number of seats available, and you'll also be able to see the number of the computer subjects that have ranked each school first. So for example, if there's school A, you'll be able to see how many of the computer subjects rank school A first. So now we're going to go over 2 things. First, we're going to go over how priorities are determined with each school. Then we're going to go over how these priorities are then used to determine the assignment. So each school has a neighborhood student. And so the neighborhood student, in this case, we've just constructed an example. The neighborhood student of A is 1, neighborhood student of B is 2, neighborhood student of C is 3, neighborhood student of D is 4. And this will change from round to round. So there's 3 things that matter for priority at a school. The first is how you've ranked that school. So the student that ranks the school the highest is going to have the highest priority of the school. If it happens that 2 students rank the school the same, the second thing that matters is which of these students is a neighborhood student, if any. If one of these students is a neighborhood student, then that's going to have the higher priority. And finally, if it's the case that both rank the student at the school the same, neither one's a neighborhood student, then the priority is going to be determined by a random number. So here, just in this example, we've come up with a random number, but whoever has the higher random number gets the higher priority. And this also changes from round to round. So let's go through an example. So for A, the most important thing is who ranks the highest. In this particular example, both 1 and 2 rank A first. 3 and 4 rank A lower. And so between 1 and 2, so they rank at the highest. Next we ask, is either one of these students a neighborhood student? And in this particular case, 1 is the neighborhood student. So 1 is going to get the highest priority at A, first because it ranks it, no other student ranks it higher. And then of the students that rank it the same, it's the only one that's a neighborhood student. Okay. Next will be 2, because 2 ranks it higher than 3 or 4. Okay. So this leaves us with 3 or 4, and we have to determine who of these students has higher priority. Well, they both rank it the same. Neither one of them are a neighborhood student, and so between them it's just determined by the random number. And in this particular case, 4's random number is higher than 3. So the next highest priority is 4, and finally 3 has the lowest priority at A. Okay, so for B, we first ask who has the highest, who ranks it the highest, and both 3 and 4 rank B first, 1 and 2 rank B lower. We then ask, are either 3 or 4 a neighborhood student? And the answer is no. And so finally we have to go to the tiebreaker, and 4 is the higher tiebreaker. So 4 is ranked highest, 3 is ranked second highest. For 1 and 2, so we're asking the same question. So first we're asking who ranks it highest, and in this particular case 2 ranks B second, 1 ranks B last, and so 2 ranks B higher, and so 2 has higher priority. So 2 will have the third highest priority, 1 will have the lowest priority. Okay. For C, our first question is who ranks it the highest. In this particular case, 1 and 4 rank C the highest. Then we ask, are either one of them the neighborhood student? The answer is no. And so finally we have to go to the tiebreaker. In this case, 1 is a higher tiebreaker than 4. So 1 is ranked highest, 4 is ranked second. Right? Of the remaining 2 students, we look to see who ranks C the highest. Well, they both rank C the same. Our second question is, are either one of these students a neighborhood student? And in this case, 3 is the neighborhood student of C. And so that means 3 is going to have higher priority than 2 will. So 3 is next and 2 is last. Okay? For D, we first ask who ranks D the highest. And so 3 is the only student who ranks D second. And all the other students rank it lower. So 3 has the highest priority. So 1, 2, and 4, 1 and 2 rank at third, 4 ranks at last. And so 1 and 2 rank D the same. Neither one of them is the neighborhood student, so we have to go to the tiebreaker. And in this case, 2 is the higher tiebreaker. So 2 is ranked second at D, 1 is ranked third, and the student who's ranked last is the student who ranks at the last, and that's 4. So now we've changed the example. We're going to show you how the preferences and the priorities are used to determine the assignment. It's going to happen in a very natural way. Okay, so the computer, once the computer knows the preferences of the students and the priorities of the schools, it's going to handle this application process internally. And so what happens is that each student is going to apply to their favorite school, and the school is going to hold on to the student with the highest priority. Any student that's rejected is going to apply to the next favorite school, and so on. So we'll work through this example. Okay? So each student applies to their favorite school. So in the beginning, 1 and 2's favorite school is A. So 1 and 2 apply to A. 3's favorite school is B, 4's favorite school is B. So that means B, 3 and 4 apply to B. So 1 has 2 applications, 1 and 2. 1 has the higher priority, so A is going to reject 2, and so this means that 2 is not going to be assigned to A, and so it's just going to hold on to his favorite application, in this case student 1. B, 4 has higher priority than 3 at B, and so this means 3 is going to be rejected, and B is going to hold on to 4. So next, 2 has been rejected, and so we know it's not going to go to A, and 3 has been rejected, we know it's not going to go to B. So 2 is going to apply to school C, and 3 is going to apply to school A. 4 is still applying to B. Right? So the only school with the decision to make is A. So here's choosing between 1 and 3. And so 1 has higher priority than 3, so it's going to reject 3. B continues to hold on to 4, C continues to hold on to 2. So 3 was rejected again, so now 3 applies to C, which is his next favorite school. So now, just to make this clear, A is holding on to 1, B is holding on to 4, and C has 2, which is holding on to, and now 3 is applying to it as well. So C looks at this and sees that, okay, 3 has higher priority than 2, so it's going to reject 2. So notice that C held on to 2 in this round, but it's still the case if you can hold on in one round and be rejected at a later round. And that's if the student with higher priority applies. Okay? So 2 is rejected by C, and so now 2 is going to apply to D. So in this round, A is still holding on to 1, B is still holding on to 4, C is holding on to 3, and 2 applies to D. And so now notice that there's no rejections in this round. There's exactly one student applying to each school, and this is when the process stops. So the school holds on to your application and continues to hold on to it unless a student with higher priority applies to it, in which case it will then be rejected and you apply to the next highest priority. And all this application and rejection is done by the computer. It's all automatic.